Welcome, everybody. The title of my presentation is Group Recommendation System with Pairwise Preferences. In this lecture, I am going to give you an introduction and then a motivation about this problem, about group recommendation system, and then the limitation that exists. Then I will talk about the methodology and result. Recommendation systems. Recommendation systems are a group of algorithms that are designed to help the user to find their interests and preferences on the set of items that can be movie, can be music, can be some products in online shopping, to have a better purchase or have a better experience. In recommendation system, normally we deal with one user, and the aim is that to find how much the user like any item and try to predict the next item that user like. In group recommendation system, we deal with a group of people. So instead of having only one user, there is a group of people who want to have a shared activity like dining together, watching a film together, and such. Here, the problem is not as easy as a single recommendation, because all the people in one group, each one has different tastes and interests, and have an aggregation between all the opinions can be a bit challenging. So it's very important to have a find item to recommend to all the people that most of the people in the group like it, and at least less people regret it. So the challenges that exist in the recommendation system is related to data. What type of data? Is it pairwise or is it single data? Cold start issue that some of the data are missing. About group formation, how the groups are formed, like is it using the clustering or not, and the similarity between the user. And also about the aggregation and consensus between the members in the group. The methodology that I used for this research has three main categories. So for the group recommendation system and data, we used single rating or pairwise preferences. About clustering or group formation, we deal with user similarity, deep learning, and GCN. And for aggregation and consensus, the user personality, consensus reaching, aggregation methods, and user contribution are the main subjects that I used. About the data. In the like previously, most of the data that are used in recommendation system are single rating data. It means that the user sees and look at the item, and if she likes it, she gives from 1 star, gives 5 star from 1 to 5 star. And if she doesn't like it much, the number of stars decrease. It is single rating data because the user only focus on one item. On the other hand, pairwise preferences is when the user sees and compare two type of data and express to what extent she prefers one item over the other one. And this type of data is more precise and better than this type, because in the previous data set, when the user likes two items, she can give them both of them 5 star. For example, if she likes Titanic, it gives 5 star. If she likes another film, gets 5 star. And they can be, one of them can action, the other one is romantic. And the recommendation system will be confused because she likes both of them, and the recommendation system cannot understand what genre is important to the user. But when we deal with the pairwise data, and she said, okay, I like both of them, but this one better than this one. It has more detailed information. So in all of the methods that I used pairwise preference data. So regarding the first challenge, cold start in pairwise preference, that there are a lot of data is missing, and the aim is to predict this data as better as possible. We proposed a method called matrix factorization per score prediction. Here we have a set of the user, and we have a pair score here for every pair of the item. So, for example, this user, he says that I like this item more than this item to what extent? For example, a number from 0 to 1. And because this matrix is not fully connected, we have some missing values, and we are going to predict it. We got the idea of matrix factorization that breaks a matrix, a bit matrix, into a smaller matrix. One matrix is for the user, so it contains the user latent features, and another one is item matrix that contains the item latent features. Here is the formula that I use for this idea. P hat ij is the predicted pair score for a pair of item. It means that how much user predict item I over j. And it is sum of the times of matrix F multiply matrix ji minus jj. So it is we somehow multiply this row with this column minus this row, this column. And then we use cross entropy as a loss function, and this H. For group formation, groups can be already existed. So, for example, you attend a conference. There are some group of people. They say, okay, this group to go to this restaurant, the other group to go to other restaurant. So the group are already existed. But in case that the groups are not existed, it's very important to form the group. And here we have a big chance to form the group based on their similarity. So the user with high similarity in preferences fall in one group, and in another group we have some other user with similarity. We have a big chance here because if some user with high similarity fall in one group, then the recommended item to them is appealing to most of them. Then most of the people in that group like the recommended item. We introduced 3 methods for clustering. One of them is called GCPP, which use dominant set clustering, and the 2 other are the diversity-based clustering. One of them based on matrix factorization, and the other is graph convolutional network. Let's see how GCPP works. GCPP is graph clustering based on pairwise preferences. It consists of 4 main steps. In the first step, we have one matrix for each user, and this matrix is pairwise preference. So the user compared every pair of items and gives her his or her preferences in that matrix. In this step, we convert this matrix to a graph, that in the graph the nodes are the items and the edges are directed. So the edges are going from the item that user like most to the item that user like less. In the second step, we use a method called SimGNN, which is based on the convolutional graph network. The input for this method is 2 graphs. So the input, we have 2 graphs. Each graph is representation of the one user preferences. And the final output is the predicted similarity between these 2 graphs. So each graph passes from graph convolutional network, attention, neural network, and finally fully connected to give us the score. To train this model, we needed a ground truth. And for the ground truth, we used top K similarity score. This top K similarity score is for each user. We extracted the K best item that user like. For example, 3 best movie that the user like. A very good point about this method is that for calculated the user similarity, we not only use the detailed information about their pairwise preferences, we also use the general preferences like top K preferred items. After calculating these pair score similarities, in the third step, we have a big graph. In this graph, every node is one user, and the graphs are weighted by the similarity of the pair of the users. So the heavier the weight means that the two users are more similar in their preferences. And in the final step, we use a dominant set clustering to cluster users based on their similarity. So in the end, the user with highest similarity fall in one cluster, and the two different clusters has the less similarity. Diversity-based clustering. In diversity-based clustering, for every user, we have one matrix. It is pair score matrix. So in this method, we have actually two methods. One of them is based on matrix factorization pair score prediction, and the other one is based on the graph convolutional network. So we give this matrix as an input to matrix factorization pair score, and then we, as an output, we have user vector and item vector. We keep this user vector for the next step. In the second method, we use GCN, graph convolutional network, to extract the user vectors. Now we have user vector from two different types. In the next step, actually we repeat this process for all of the user. In the next step, based on the similarity between the two users, which calculated with this equation, we have the kernel matrix. The kernel matrix contains the pairwise similarity of the users. And here the clustering starts. So first we have a set of users. We have a set of users which are not clusters. We initialize the clustering by assigning one user to the cluster. In the second step, we calculate the diversity score between the existing cluster, one by one, with any of the unclustered user. Okay? And then we find the minimum, the user with minimum diversity score, and add it to this cluster. So the second member will be added. And we repeat this process until this diversity score is under a threshold. After that, this cluster will be finished and we start another cluster. And we repeat this process until all the users assigned to any cluster. So this is the clustering method, and the diversity score here is calculated based on the how much this user UN add diversity to cluster CT. And it is calculated based on the logarithm of determinant of this matrix. So here I explained the three methods for clustering. The third main challenge regarding group recommendation is about aggregation and consensus. Here we have a group, so the groups are actually formed, and we want to see what is the final user preferences. One very simple solution is to just average between everyone's preferences and get the group preferences. But we know that in reality, it is not like that. Everyone has a weight. So some of the people, some of the person's preferences can have more effect on the group's preferences. For this, we have several methods. One of them is personality, considering personality of the user. Two methods based on the user contribution in the final decision, and one method based on the coalition of the user subsets. Let's see how they work. First, personality of the user. Here again, we have a group of users. They want to decide on one item. They talk to each other, and because in this method, we are going to simulate the real life. In real life, when a group of people want to decide on one thing, they talk together. And one person is very assertive and stay on his own opinion and try to convince others to follow them. There are also some people who are very easygoing, just follow the others and they change their mind. So if in the beginning they have some opinion, after some discussion with others, they change their mind. So we try to simulate this into here. What we did, first we have a psychological test named TKI. The result of this test will show how much cooperative or assertive is a person. So this PRI or J, here it shows the amount of assertiveness of a person. With this formula, we calculate a weight. It is the influence of the user I on user J. How much user I can change the user J's opinion. And the heavier the weight, it means that more influence they have on the other person. So we calculate this weight. And finally, using several steps, we reach the consensus. In this diagram, I show an example. So we have different people with different personality. For example, the red person 1, has 0.2 from 0 to 1. 1 is assertive, 0 is like very cooperative. Person 2 is very assertive. The personality is 1. Person 5, the blue one, is 0. It's like very easygoing. And here in the beginning, we have their rating on one item. So one of the red person have 5, the brown and the purple has 4, and such. After they discuss together or we apply this weight on their opinion, in the second step, we see that they have changed their mind and their decision become closer and closer together. And after some steps, we can see all of them reach a consensus. The beautiful point here is that we can see this brown person, the person who is very assertive, he changed his opinion very little. It just goes from 4 to 3.5, just a little bit change. But this person, the blue one, person 5, goes from 1 to 3.5, changed a lot. So it means that we could show it very beautiful in this scenario. The next idea is about user contribution in the final decision. The idea here is that for calculating the weight of every user in the final decision, we saw that how much a user preferences is similar to the group preferences. So, for example, if the whole group like the movie Hair, and in this group I also like Hair, and the other people doesn't like it, it means that my preferences is very similar to the group preferences. So I will have more contribution to the final decision. So I will have more weights than the others. So here we have several clusters. Each cluster has some user in it. For each cluster, we have this step. For each cluster or for each user, we calculate the W for that user. Here I use the picture of the human to better show the idea. So in this step, we use the idea based on the Shapley value. And what we did is that we extracted all the possible subsets of this group that include this user. And then calculated the Shapley value for each subset, and we have the contribution score for any of them. And then we got the average of these scores and got the weights for this user. So we repeat this process for all of the user, and finally we have weight for each user. So it is one idea. Now we calculate W and with one idea. So we try to minimize the diversity. In the second idea, which comes from the Wonderful Life utility, and we try to maximize the similarity. So in each cluster, for every user, we calculate the weight of that user based on the similarity of this user preferences to the group preferences. This similarity is calculated based on the similarity of two vectors. So the user vector and the group vector. User vector is the vector contains the user scores on different items, and the same for the group. So now we have the weights for each user on two different methods, and we use it using weighted averaging. So we have the group scores on the items, and in the end, we extract the highest ranked items and we recommend them to that cluster. So here is the second idea about aggregation. Actually, second and third. And next idea is about the coalition of the user subsets. So previous idea was focusing on every single user. Here we are focusing on subset of users. So for example, here we have a group of users. We want to see what is this group preferences on the item. But here what we do is that we break them in small subsets. For example, we have 5. We have a subset of 3 here. We have a subset of 2 here. And then we see these subset preferences, how much this preference is similar to the whole group, and how much is this subset preference to the whole group. So if any subset have a higher score, it means that they are more similar and they can have more weight. Let's look at this. So we have a group of 4. We extract all the possible subsets of the user. And with a Shapley value, we calculate the coalition score of them. Here, when we have the coalition score, we can sort them from higher to the lower, and only keep the subset with highest score. After we keep them, we look at the users that are repeated or are frequent in the highest subsets, for example, this woman, and extract the k-best user. Already, we calculated for every user their user item scores, and we bring them here. So in this process, the user item score is calculated. So we bring it here only for these 2 users, because these 2 users are the candidates for the whole group. So we only consider the preferences of these 2 persons. We have it here, and then we extract the frequent item from this set and recommend it to the group. So the methodology finished now, and I would like to talk about the result. I just reported 2 types of the result. One of them is the prediction result, and the other one is the evaluation. For the prediction, I compared our method for matrix factorization per score prediction with another method in state of the art, which we call it HCHS model. Our method is with green, and the other method is with red. Here is the prediction error and ranking error. And what happens here is that we started with a full matrix without any missing value. And every time we increase the number of missing values to see how the model can perform better. And we can see that as the missing values increase, both of the models will increase in the error, but HCHS will have higher error. And also, it stops prediction when the number of missing values increase more than 75%. And it's very important because our model can work even when the number of missing values is 95%. And the main reason is that this model works based on the additive consistency. For this model, it is very important that we have the user pairwise preferences enough. But our model even can work when there are a lot of missing values, and the reason is that this model doesn't rely on the pairwise scores. It relies on the user similarity and item similarity. So if we have a new movie, we don't have a lot of pairwise score on it, but we know that it is action movie. And we know that users like action movie. So these two movies are similar. So they can have similar scores. And about the evaluation result, what I did, I put all of the clustering methods and all of the aggregation methods here to see how the precision, recall, F1 score, and fairness work. And among them, I can see the methods with higher fairness belongs to the methods like GCN diversity and GCPP. These two are the methods that use graph clustering. And the same for this dataset. And among the model for the aggregation, the ones with Wonderful Life utility had the highest F1 score. For the future work, there are a lot of suggestions. One of them is about collecting a new data set with some information about the user and having the opportunity that user change their mind. About clustering, some idea for clustering initialization. About user, to have the opportunity to have dynamic preferences, and also about considering some behavior trait. For example, if the user is very curious, it seems that maybe she or he likes to have receive more diverse recommendation. And about generative AI, it's very good to have some models like LLM and NLP for extracting the textual features from the items and use them in the training of the model. And also for the group dynamic, another idea is to combine neural matrix factorization with autoencoders to have a group prediction of the group rating. This idea here, This idea here for generative AI are suggested by the DEAR committee. And here is the list of my papers. 3 of the papers are published and 2 of them are submitted. And thank you.